Hello, distance learners. You can turn in your 7.8 on the slide today. There's a Google form for it. Meanwhile, I'm going to collect
Oh, you're talking about like number 3?
your 7.8. Thank you. And then we are going to do test review. I'm going to record it, so it won't take us too long. And then the rest of the hour, you can go work on a review assignment. We're going to work on that all of tomorrow. And then we shall test on Thursday. I'm going to get closer to my computer. Test is Thursday, guys. Well, look who showed up. All right. Just a second. There we go. Oh, another one. Yes. Oh, thanks. So I probably won't ask you a whole lot of questions during the review. We'll probably just plow through it here since I'm recording it. Let me make sure my mic is working. Is my mic working? All right. And exit. And begin. So 7.1 and 7.2 were just modeling situations that result in differential equations and verifying. So an example of that would be just knowing how to set up a differential equation or a derivative, always indicated by a rate of change. So when it says the rate of change of y with respect to x, you write dy dx. Is, you write equals. Proportional, you put a k down. The product of t and the rate of change, another derivative, of w with respect to x. It's just on reading it, all right? So are we good with that? It's pretty straightforward. There's only one of those on your test, but I do have you set one of them up, all right? So when it says proportional, we use that k. Anytime it says rate, we set up a derivative. And the other part of the first part of the chapter was just verifying solutions. It was basically a trial and error thing. So you would just check which ones of these, when you take their second derivative, subtract 5 times their first derivative, add 4 times it, gives you a 0. You can't answer the question until you do all 3 of them. But I'm only going to do one of them. All right, just so to show you what I mean by, I'm just going to grab one here. Let's do 3 and see if it works. So when you take the derivative of y, and it's some constant e to the 4x, its derivative, the constant would stay put, we do e to the u du. So there's the first derivative. That will go in right here for y prime when I try to see if this is actually a solution. If it's a solution, it has to work. It's like in elementary school, if I said, hey guys, is 4 a solution to this? And you'd say, no, it doesn't work. That's what this is. You just have to plug it in and check, but you can't plug them in until you take the first and second derivative. So again, we have this constant out front. We have e to the u, but then we multiply by its derivative. So when I set this up, by this I mean, those of you at home, you can't see what I point at, so I'll go circle it. When I go check and see if this solution is a viable one, I take y double prime, 16c to the 4x, that's this. I subtract 5 times the first derivative, that's this. And then I add 4 times the original, which if I go back here, it was c e to the 4x. So 4c e to the 4x. And I see if that's truly equal to 0. If it is, Roman numeral 3 is a solution. Is it good? Yes, right? I get 0 over here on the left, 0 equals 0. So there's no other way to do this than trial and error. All right, next step, we talked about slope fields. You'll need to know how to sketch them. So we'll talk about 7.3 first. When you're sketching a slope field, you just do it at the dots provided. I think on your test I don't have as many dots. So I'll just start on this one. The easiest thing to do is find where the slope would be 0. So I'm going to write dy dx will equal 0 anywhere where x is equal to -1. So all along here, 0, 0, 0, 0. However, I have to be careful of one of those that I made. Do you guys know which one? I just asked you a question, but go ahead and answer me. The 2. Yeah, the derivative actually doesn't exist there because of the denominator. So just be a little careful. After that, there's really no shortcuts except to start plugging and chugging and just watch your arithmetic. So we'll just do a couple on here. Let's say at 1, 3, what would my slope be? It'd be 1 plus 1 over 3 minus 2. So I do a fairly steep tick mark. Go do 2 more. And again, we're just using this to review, so I'm not going to sit here and do arithmetic on 12 dots. But let's go maybe do 1, 1, just so you would know how to draw that. At 1, 1, we would do 1 plus 1, which is 2, over 1 minus 2, which is -1. We'd have a very steep downhill, about the same steepness as the other. All right, any questions on making slope fields? They're just a pain in the butt, but they're easy, right? Unless it's delta math, that's super picky with the slopes. All right, reasoning using slope fields as well. So let's look at this. It says, by the way, I'm going to locate the origin on here just so we can, here's the origin, just so it's a little, it's weirdly labeled. I screenshot this, but anyway, it says, when are the slopes non-negative? What does non-negative mean? Positive or what? 0. Yeah. So when it says, when are the slopes non-negative, I need this thing right here to be positive or 0. If it says, when are they positive, then I take off that equaling 0 part of it. So where are we 0? Anywhere where x is greater than or equal to 1, right? So everywhere to the right of 1, and anywhere where y squared, right, is equal to what? 0. Yeah, because otherwise the y's actually are always good, but we need to be to the right of 1 or equal to 1, so let's go find that. It'd be kind of over here. That's where we're non-negative. You can purposely put the graph on there so you could see it. All right, so pretty easy. We're going to go to 7.8 next because it doesn't need a whole lot of work. Yesterday's stuff, exponential models. A population grows according to this equation. This means, hello, exponential growth. It means don't separate, don't integrate. Y always equals CE to the KT. All right, that's how these always start. And then you need to provide C and K, and in this case, only K, because that's what it asks for. It just says, if the population doubles every 25 years, then what's the value of K? You might say, they didn't give me the C. They don't need to. Because if C doubles, what would this be over here? Twice it, right? You could put in a fake number, and you could make it go from 10 to 20 or 50 to 100. You could like physically make it double Priestley, but really you're looking at a 2 on the left regardless of how it doubles or what it started at. All right, so this is 2e to the k times 25. That's what it equals. So how do I go ahead and solve that for k? I have to sneeze, sorry, I'm gonna put this on. Population doubles every 2 years. We have 2 equals, sorry, I forgot my equals on there. 2 equals e to the k times 25. What do you just do on your calculator? Natural log of 2 divided by 12. Yeah, I shouldn't walk away from my mic. Sorry, it's hard. I don't normally teach like this. I'm not talking to you guys. But I've been trying to do recordings ahead of time and I didn't have time for this one. All right, so yeah, natural log of 2, 20. Natural log of 2 over 25. My allergies are crazy today. It's hard wearing a mask when I have them. Okay, now let's go down to the next one. A dose of 100 milligrams of drug is administered to a patient. I would go like that. Hello, initial. The amount of drug in milligrams in a person's bloodstream at any time is given by A of T. The rate at which the drug leaves the bloodstream can be modeled by this differential equation. That's exponential growth and kind of nice. What variable did they hand you that you need? They gave you K. Yep, so when I solve this for A, I'll get C e to the K T, or A of T, if you want to write that. But that's kind of nice because C was handed to me, the initial amount. K was also given to me. So understand that sometimes they're quite simple. That will give me the amount in the bloodstream after any given time. Right? We good with that? Was yesterday's stuff. Moving on to the next page, we're just doing an overview. The mid chunk of the chapter and the majority of your points on the test come from solving your differential equations using separation of variables. All right, so I have two samples. You can never predict what they're going to be. They're all different. But I chose two that have something weird that happened just because we don't practice the easy ones, right? The weird part on this guy is it doesn't look like it can be separated because of the plus. But if you factor it, then you can. So sometimes if it doesn't look separable, it is because that's the only thing you know how to do. It's like a cadence stroke. Oh my gosh, I have to sneeze again. So, oh, gross. To my mouth. Oh, you guys, my allergies. Sorry, those of you at home. My allergies are going crazy today. Can you see it in my eyes? Ellie, you see it? Oh, it's watery. All right, sorry. So if it doesn't appear separable, it is, because otherwise I wouldn't have it on the test, and neither would College Board. So when I separate this, I do 1 over y plus 2 dy is equal to 2x dx. And normally I'd say, what do we do next? But you guys can't hear when they answer, so I'm just going to say we integrate next. Be careful on the left. This is straight up natural log. If I take the derivative of this, I would have u prime, which is 1, over u, which is y plus 2. But be careful, I'm going to insert something in here. What if there was a 5 right here? And then you would do that. What else would you need? Do you know? Oops, I shouldn't walk away from my mic. Because now when I do u prime over u, I get 5 over 5y plus 2. What would that need? A 1/5 fraction correction. It's really u sub, where u is 5y plus 2, du dy is 5, right? Not 1. So if you need to write the u sub out, do it. In particular, what happens a lot with the word problems, don't you do this, is and you found it hopefully on the exponential sheet, the last 2, I think, on yesterday. Jeez. It looked kind of like that. Then what do you need in front of it? A negative. So just beware. This one was straight up absolute value, but that doesn't mean natural log, it doesn't mean you always just have that. You got to be careful. This would be x squared plus c, right? What's up next? Exponentiating. I should do it in 2 steps, but I'm not going to right now. I get the absolute value of y plus 2. Make sure you know how to deal with this over here. We've done it a lot, right? It'd be e to the x squared times e to the c, which would just be c e to the x squared. Now, if you allow c to absorb the absolute value, like if you're like, well, c equals plus or minus e to the c, it's actually legal to drop them right here. Or you could just put a plus or minus in front of it. It doesn't really matter. All right? And then you'd subtract 2 and you'd be done. All right? Any questions about that one, you guys who are in here? It should seem fairly easy after the delta math, right? I killed you on that one. So let's go look at the next one. I'm going to separate. 1 over 8 minus y is equal to just 1/5 dx. All right? When I do the antiderivative, I'm not going to take this one all the way out. But be careful on the left, right? I mean, correct? Luke, why do I say be careful on the left? What do you think?
Just say because you need a
I need a negative out front. Yeah, if I take the derivative of this, I would get a negative 1 over 8 minus y. And so I need to, again, be very careful about that. And on the right-hand side, I get a 1/5, right, x. Be careful if there was, like, maybe if this wasn't here. This threw kids off last year, I remember, with something. So again, you leave the 1/5 there, but what is there when there's nothing over there? What would this actually be right here? I'm drawing it so the distance learners can see. A 1. Yeah, so when you don't see it, it's there. But ours was a 1/5, so we're good. And then don't forget to get rid of this before you exponentiate. So I'd have 8 minus y equals negative 1/5 x. How are we doing so far, Peyton? Good? Then I would exponentiate. And I get absolute value of 8 minus y equals e to the negative 1/5 x. This is a particular solution. When do I find c, which I actually forgot to put on there? When do I find my c? Just move my screen. When, guys, having a morning. Do you feel bad for me, guys? Lily, do you feel bad for me? My allergies are going crazy. My screen's going crazy. Everything's going crazy. My question was, and I was trying to draw a C on here in my question was, when do I find it? That's a good question, right? You can speak. They can't hear you, but I'll repeat what you say. So how about Annika? When do I find that C? Anytime after I integrate. The word on the street is that it's usually best to do it right away. I don't like it with the ln in there, so maybe I do it right now, but they usually say the sooner the better. I honestly, if you're careful, don't mind if you wait till the end. I'm not going to finish that because we did so many of them, but you can find it. If you didn't hear what Annika said, she said anytime after you integrate. So it says, what else should I study? You will have 2 FRQs, and so I'm telling you that one of them will be like the bird and the potato one from last week. I would look at those. Okay, you're going to easily finish your review in class today and tomorrow. You won't have anything to do at home, right? I always do that for the reviews. I give you enough time in class to do them. But I would spend some time maybe looking at the bird and the potato, and anything that wasn't smooth. You still have your 7, 6, 7. You still have your work, right, for those sections I didn't collect on purpose so that you could look. There were 5 in each section of differential equations. I'd look and see, are these smooth now? All right, so I'm going to give you the review. Those of you at home, I linked it. It's due Thursday. They have enough time in class to finish it, and the key is posted. So, and this I'd like you to work on your own. I know we've been working together on some of these, some of you, but not. Sorry. I'm having mask issues too. That's like the screen isn't tight now. Allergy issues, mask issues, smartphone issues. Frank's here! Good morning, Frank. All right. The key is posted to this. I would maybe do one, check one, do one, check one. So you might want to open up your Chromebook. Keys are super important to the reviews. Anything that you get wrong, I'd circle. So, like if you do that first one, you're like, oh, I got part C wrong, I'd circle that. All right? So go ahead and begin. Oh, before I turn off my recording, there's one of them I'm going to have you change. So I'm going to come up here. Go to number 5. I've got to find what I want you to change it to. I think I put it over here. Number 5, I'm going to have you change because that's actually not a separable. It's already separated, and so it's not how you're going to be tested. Number 5, we're going to change to this. dy dx, I'll write it up here so the people at home can see it. Number 5 is going to become dy dx equals y plus 1 to the 3 halves and y of 3 equals 0. Change number 5. So cross off what's there with the 8x over whatever, 18x. Cross that off and change number 5. All right, now I'll stop recording. You guys have the